Dear friends, welcome to the video content on Euclid geometry. In this content, we will learn Euclid's definition, Euclid's axioms, Euclid's postulates, and equivalent versions of fifth postulate. Introduction. To understand the geometry, correct formula and defined volume, we need Euclid geometry. For example, truncated prism shown here as complex volume and surface area, and to understand it we need to take help of Euclid geometry. Dimensions. Solid has shape, size, position, and can be moved from one place to another. These are three-dimensional entities. Boundaries are called surfaces, which are two-dimensional. The boundaries of the surfaces are curves or straight lines, which are one-dimensional. These lines end in points. Points do not have dimensions. If we consider the solids, surfaces, lines, and points, then each extension is defined by dimension. Euclid's definition. Some of the Euclid's definition are as follows. A point is that which has no part. A line is breadth less length. The ends of a line are points. A straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only. The edges of a surface are lines. A plane surface is a surface which lies evenly with the straight lines on itself. And there are more such definitions which you can find out yourself. Euclid's axioms. Besides definitions, there are some statements which are accepted as truths. These are called axioms. Some of the Euclid's axioms are as follows. Things which are equal to the same thing are equal to one another. If equals are added to equals, the wholes are equals. If equals are subtracted from equals, the remainders are equal. Things which coincide with one another are equal to one another. The whole is greater than the part. Things which are double of the same things are equal to one another. Things which are halves of same things are equal to one another. Euclid's first postulate. This postulate says that a straight line may be drawn from any point to any point. This is based on the axiom that given two distinct points, there is a unique line that passes through them. This can be demonstrated as shown in this figure. Here, we see that out of many lines drawn from each of the 2 points, one line is common to both, which is also unique. Euclid's second postulate. The second postulate says that a terminated line can be produced indefinitely. Note that a terminated line in Euclid's geometry is same as line segment in today's terms. So, in other words, it says that a line segment can be extended on either side to form a line. Euclid's third postulate. Third postulate says that a circle can be drawn with any center and any radius. Euclid's fourth postulate. This postulate says that all right angles are equal to one another. This is evident from the fact that all the right angles are equal in measure, which is 90 degrees. Euclid's fifth postulate. The fifth postulate says that if a straight line falling on two straight lines makes the interior angles on the same side of it taken together greater than two right angles, that is 180 degrees, then the two straight lines, if produced indefinitely, meet on that side which the sum of angles is less than two right angles, that is less than 180 degree. Theorem. Based on these definitions, axioms and postulates, we can deduce some theorems. For example, here we try to prove a theorem which says two distinct lines cannot have more than one point in common. To prove this, given two lines L and M, we need to prove that they have only one point in common. For the time being, let us suppose that the two lines intersect in two distinct points, say P and Q. We have two lines passing through P and Q. But this assumption clashes with the axiom that only one line can pass through two distinct points. Hence, the assumption that two lines can pass through two distinct points is wrong. So, we are forced to conclude that two distinct lines cannot have more than one point in common. Equivalent version of Euclid's fifth postulate. For every line n and for every point p not lying on n, there exists a unique line m passing through p and parallel to n. The result can also be stated in the following form. Two intersecting lines cannot be parallel to the same line. As you can see in the picture, the lines which intersect m at p are not parallel to line n. Based on this knowledge, let's try to solve an example. Example 1. The question here is, there exists a pair of straight lines that are everywhere equidistant from one another. Is this statement a direct consequence of Euclid's fifth postulate? Explain. Now let's solve this in the following manner. Take any line L and a point P not on L. Then, by Playfair's axiom, which is equivalent to the fifth postulate, we know that there is a unique line M through P which is parallel to L. Now, the distance of the point from a line is the length of the perpendicular from the point to the line. This distance will be the same for any point on M from L and any point from L from N. So, these two lines are everywhere equidistant from one another. This shows that this statement is a direct consequence of Euclid's fifth postulate. Thank you. This content was developed under Akash School project. This is project funded by NME-ICT and MHRD Government of India. If you wish to contact us, please mail us at the given email ID. Thank you for watching this content.